Welcome to this episode of the AEC Engineering and Technology podcast dedicated to helping engineering professionals find technology that fits their needs. I'm your host, Nick Heim, and in this episode, we have the pleasure of speaking with two distinguished guests from the field of Geographic Information Systems, also known as GIS and Planning, Drew and Hart, both with Stanley Consultants. Drew leads as the Master Planning Department Manager, while Hart serves as the GIS Coordinator. Together, they'll speak about the evolution of GIS technology, the changing landscape of GIS user base, and the critical role of mobile GIS applications in enhancing project delivery and client satisfaction. But before we get started, here's a quick word from our sponsor for today's episode, Stanley Consultants.
For over a century, Stanley Consultants has been at the forefront of engineering innovation, relentlessly committed to improving lives and building a resilient future. We collaborate with government agencies, utility providers, and private industries to solve some of the most complex challenges in energy, infrastructure, and more. We put people first, leveraging cutting-edge technology and multidisciplinary expertise to deliver differently and exceed expectations. Be a part of our journey to create a connected, sustainable, and enriched world for all. Get in touch with our Stanley Consultants team today.
All right, Drew and Hart, thank you both for joining us today and welcome to the show.
Thank you.
Thank you, Nick. Thanks for having us.
Absolutely. So we'll get right into it. I like these tandem interviews, as I was telling you guys earlier, because it provides kind of a different feel. So why don't we get started with just telling the audience a little bit about both of yourselves and what you guys do on a day-to-day basis at Stanley Consultants.
Sure. So Hart, I'll go first and
Okay.
hand it off to you. So Drew Rotschafer here. So I've been with Stanley since 2005. We've been using GIS mostly as a desktop in the early years, but I think, Stanley Consultants been doing it for close to 40 years now. And, back when I first started, it was a lot of just desktop, cartography. There's a little bit of field data collection, but it was still sort of a newer technology, and today it's evolved into quite a bit more. But it's been really awesome just to see how the technology in the industry has changed just over the last 15, 20 years.
And hi, everybody. Hart Gilchrist. I'm the GIS coordinator here at Stanley. Been at Stanley about 2.5 years, and prior to that, I've worked at a number of other different architectural engineering firms, as well as a long stint at an electrical distribution co-op. So I've been working in GIS pretty much my entire time with that, mostly with Esri products. And for any of the older listeners out there, I remember old desktop Arc Info, where you had to code everything in a text editor with VMAX and things like that. So it's been a long trip, long background to sort of build new products upon. So that's fun.
Excellent. Well, thank you both for the introduction. And Drew, why don't we kick it back to you? So why don't we start off first by explaining to the audience a little bit about like GIS, what does the acronym stand for, kind of what it is, and how that technology's evolved over, say, like the past 15 years or so.
Yeah, absolutely. So GIS is Geographic Information Systems. If you talk to a land surveyor, they might say, get it surveyed. And that's what the GIS acronym stands for. But we'll ignore them for today's podcast. So really, Geographic Information Systems, if you kind of think about it, kind of like from a cartography standpoint, it's basically that geospatial sort of mapping interface. And it's a way to essentially manage all of your assets. The way that Stanley Consultants uses it a lot is we have, a number of clients, you name it, maybe it's Department of Defense, could be, transportation, water, water resources. We basically use it for modeling purposes. Could be utility modeling, could be floodplain mapping. We also use it just to, for asset management to help with capital improvement plans for, municipalities or again, like the federal government. But basically they get to know where all of their assets are located geospatially. And then you can assign basically attributes to each one of those. So they know, just for an example, a pipe, is it an 8-inch pipe? Is it a 12-inch pipe? And you can take all that information and put it into a model to kind of help understand, what the different, capacities or volumes or flows are, condition assessments. Honestly, the capabilities are endless, as we're finding out. I often tell people that if they're asking, can GIS do this? My knee-jerk reaction is yes. And then we find the way to make it happen. But it's been pretty incredible. These days, instead of just kind of a desktop version where basically anybody that just has the software on their desktop can use it, it's now become so much more. Now it's kind of open source environment where you send it out. You can do field data collection. where you have hundreds of people, collecting data all at once, and that gets uploaded, kind of almost on a real-time basis. But it's now expanded to just a much wider user base.
And like we were talking about earlier, Drew, right? So I think a lot of engineers touch GIS in some way or another without realizing it. So my background is in structural engineering, and we primarily do restoration of parking structures, right? I've got a plan. I can tell you where all my defects are and so on and so forth, right? Not maybe so challenging for a single structure in one location, right? But you go to a municipality or a city, right? Miles and miles of roadway and other assets and infrastructure. It sounds like that could be, a case where GIS shines over just say a single plan, right?
Exactly. Yeah. And especially when you have just an extensive network of assets. I mean, the transportation market, that's a really good example of, you may have, miles and miles of highway that you have to manage. And if you think about it, when you're driving down the highway, there could be hundreds of signs. There could be, stormwater culverts. There could be guardrails. There's just so many things that it's not just pavement that you're driving down. There is a lot that goes into that. And trying to keep track of that, there's a lot of, the federal highway has mandates that you have to make sure that the signs have a certain amount of reflectivity for safety reasons. You have to make sure that there's a plan to replace those signs every so often. Perhaps your pavement has cracks in it, and you're trying to understand, okay, do we need to budget to replace this, in the next 2 years or the next 20 years? You can basically use, there's so much technology out there that you can basically scan using, 3D LiDAR scanning to determine where the cracks are, the severity of the cracks. And then you can take that information and then build out, the cost to basically fill those cracks or replace the concrete. So again, sky's the limit on these things. And, when we show all these capabilities to our clients, they're always just very impressed. And a lot of times we get the question of, gosh, why didn't we use this a lot sooner?
Exactly. And Hart, here's one for you. Transportation being a pretty basic example for most civil engineers of an industry that can take advantage of GIS, right? But how has the GIS user base changed over your career, especially in terms of the different disciplines and industries that now rely on the technology?
Absolutely. Yeah. I think the way the user base has changed is GIS has sort of come to the people, for lack of a better term. You mentioned earlier that that users are sort of incorporating it. They may not even know that they're using it at this point. Drew did a really nice background of GIS and how it's changed. And in some regards, it's almost sort of the best of cartography mixed with the best of your Excel spreadsheets. And you're taking the user that knows how to use the spreadsheet and, the cartographer who knows how to place things on a map. And the two of those sort of come together in a functionality that really anyone can use. And so ages ago, I was talking about programming on ArcInfo. It was an expert at a desktop. And nowadays, you've got a user, an engineer, a CAD tech, administrative assistant. Any of them now are incorporating uses and pieces of GIS, whether it's an office location map, finding out, where does this employee work, which office, to field data collection and having real-time data updates. So we recently had people out on a highway doing a sign inventory. This is on an interstate. Traffic's whizzing by. You don't want to have them out there longer than you have to. So as they're collecting it in real time, we have people back in the office doing real-time data QA, QC. You don't have to send somebody back out there because someone's already corrected that typo that, they thumb typed out there while they were in the middle of traffic. Safer for everybody. The data gets done a whole lot faster. The key point there is that neither of those users had to be GIS experts anymore. They could be transportation engineers who really know what they're looking at out in the field. They could be an administrative assistant who can QA, QC data, make sure that it looks appropriate, that it's typed appropriate, it's ready for a report as soon as it comes out of the GIS database. And that's an incredible savings of time. And you're getting people who are really good at what they do using the tools that we're now providing rather than being the expert.
I'd venture to say that much like a lot of other technologies, right, GIS has probably benefited from cloud storage and some of the other advents that, like you said, went from maybe just a single person at a station using the software to just having any number of different users all collaborating on a project at one time.
Absolutely. The cloud storage and the interconnectivity has just exploded, over the last, 5-10 years with the internet. And the ability to real-time data in the field and multi-user environments, and it's really, really spread the user base out to any number of different people at any given point in time. So,
and Drew, let's kick back to you for this one. So we've talked about kind of like integration of like users and different skill sets, right? But what about data sources? And how does GIS integrating different data sources provide a comprehensive view of projects?
Yeah, Nick, that's a really good question. It's pretty incredible. I'll give you an example. So a new transmission line project, we are actually working on a project now that actually spans across 4 different states. And of course, within those states, you have various counties. And within those counties, they may have, the assessors tracking all of the land parcels. So, when you're trying to put together a new, plan for a new route for a transmission line, you have to work with every single landowner that new transmission line is going to cross their land. So putting together kind of a list of all those parcels, you have to basically work with each of the county assessor's office. So that's, multiple data sources. And what's nice is GIS, what I would say one of the best technologies that has kind of come out is what they call REST services. So REST services, if you kind of think about it, it's basically you connecting to other people's data, and you're bringing that all into one single interface. And so if you have, let's say 10 different counties, you can actually bring in all of their data, and it's reading their data in real time. So it's not like a snapshot in time. It's not that you ask the assessor's office, hey, can you send me, a file that shows all of the landowners for this particular date? Because as everyone knows, there's so many different, land owners change all the time, quite frequently. So you really need to kind of have that real-time data source in order to do this. And so those REST services are very important in the line of business that we do, because you can then look at all the data in real time. So there's the landowners, but then, you may have multiple consultants that are working on this. Maybe it's a joint venture partnership where it's Stanley Consultants and some other AE firm that's working together. And so we need to connect to their data. They need to connect to our data. Potentially there's other government agencies, environmental agencies. So, there's National Wetland Inventory, so NWI. You might need to know where the wetlands are so you don't impact wetlands. There could potentially be archaeological, findings out there. So you want to kind of tie into the state's database to determine, where some of those areas are. You name it. There's just so much data that's involved with some of these projects. In order to just bring that in together is very important. So everyone kind of understands the entire picture of the project.
And kind of like we were talking about earlier, right? So this is not just, right, some assessor's office sending you a spreadsheet every 2 weeks, right? You've got live real-time access to this data, as do all the other collaborators on your projects, right? Which to me, it seems like a no-brainer, but it sounds like it wasn't always like that.
It really wasn't. Yeah, I was going to say 15 years ago, that was very difficult to come by. So it's so much more powerful these days than it ever has been. I mean, some things that you kind of take for granted too. I mean, sometimes you get a letter in the mail and you kind of take for granted like all the work that was put into determining why you got that letter. But if you're a landowner and somebody's, looking to potentially either put an easement on your land or, do a right of way, GIS can help with that. So basically you can do an intersect wherever that transmission line intersects that land parcel polygon, it will export out basically a mailing list that says, okay, here's the first and last name of the person as well as the address. And then you can just, automate that and print out envelopes that basically say, hey, your land is being looked at in terms of a right of way or maybe some public feedback or something like that. So things like that, it's just use GIS for all the time. You don't even realize it.
And Hart, I mean, we can also talk about like the different types of applications and tools you guys are using, right? So my understanding is Stanley is primarily a Microsoft and Esri shop. Could you just talk a little bit about some of the programs you guys are using, like ArcGIS Pro, Esri Enterprise Portal, Field Maps, etc., and like to the layman, like what exactly do those programs do, and then what do you guys use them for specifically at Stanley?
Sure, happy to jump into that. I just want to piggyback on something that Drew had just talked about. And while GIS is consolidating all of this data together, and you're absolutely right, it gets people real-time data. That's really nice. But it's also what it's doing is it's allowing the experts in those data to manage their data. And we're still getting the benefits of it. The assessor is mandated to take care of their data. We're getting the benefits of them managing the data in real time rather than, as you say, cuts of data every so often. So experts maintaining their own data and we get all the benefits from it that's a win-win. So, but as you mentioned, Stanley is basically Microsoft and Esri. And Esri is the GIS side. Microsoft, obviously everybody knows Microsoft. So on the GIS side, Stanley, we have desktop. So we've got the old ArcMap, which is slowly being retired as it's at the end of its life cycle. ArcGIS Pro, we're migrating everybody onto that. We have Enterprise Portal set up internally. So we have an enterprise level SQL Server geodatabase on the back end. It serves our Enterprise Portal web mapping on our side of the firewall, which is used extensively by all our user base across the company for web mapping, viewing data, sketching things up, and as sort of the repository for any of our field data collection applications, using primarily Survey 123 and field maps. So depending on the complexity of what people want to use it for, from the dead simple, I want to go out and take a photo and type in some notes. I mean, I call it a digital notepad, or almost notations to cameras. We could throw those things together in 30, 40 minutes, get people out in the field collecting the data they want. Really just sort of a way to track their progress in the field, all the way up to some amazingly complex Survey 123 applications. I had a 35-page requirements document come to me for how complex this Survey 123 document was going to be. And users ended up being out in the field for over a month, collected, I think, 8,000 points and 14,000 pictures for this single project. So, I mean, it does a lot of stuff, and it scales beautifully. And all that stuff was stored on our side of the firewall, so no issues with security, and can start generating reports from that, can export to different users. They're all taking advantage of that information being processed through operational dashboards and web mapping. Select few of those users have edit capabilities, so then, like I had mentioned previously, they can QA/QC it. So really taking advantage of sort of the breadth of services all the way from the field to the desktop to the web, all on our side of the firewall. In addition to that, we have an ArcGIS online presence sort of out in the cloud, obviously. And some of our projects require being out publicly available using, public feedback maps. When there's traffic routes or options and stuff, we can go out to the public and say, here, public feedback opportunities. ArcGIS Online we use for that. It gets a little bit dicey. We have to thoroughly vet what kind of client we have and their data security requirements. Certain clients, particularly the federal government, you can't put certain data out in the cloud unless the repositories are what's called FedRAMP certified. So whether it's FedRAMP certified or not is a key thing. Whether we keep it internal, we put it outside, and that's done on a client and a project by project basis. So
yeah, and Nick, that's sort of the important piece. So kind of like we're discussing before is, there's a lot, the user base for GIS is a lot larger than it used to be 15 years ago, which is a great thing. The one thing that we constantly have to train and address in our line of work is some of the novice users that maybe don't understand, how public some of this information can become if you put it on ArcGIS Online, for example. So we just have to, constantly talk with our teams, make sure that they understand, hey, certain projects, like, for example, federal projects often have that clause where you're not allowed to put it on, public-facing forums. So we just have to tell them, hey, you have to use ArcGIS Portal, which is behind our firewall, if you want to have some of this, use some of this data to work with the teams. So that is kind of the caveat to this ArcGIS Online software.
Which makes sense. And I think a recurring theme on the show, right, is just like with anything, right, technology, there's going to be training. There's going to be some aspect of teaching people how to use what you have just to make sure they're not getting into trouble, right, guys?
Exactly.
Exactly. I realized I didn't really bring up any of the Microsoft. And so Stanley obviously has the full Microsoft Office suite. We have OneDrive for data sharing. We've got a SharePoint site stood up to be able to, landing repositories to be able to disseminate some of our GIS, how-to documents and documentation. And as well, we also are really jumping in deep with Power BI and data analytics. So we have an enterprise analytics group that GIS now is working fairly closely with and teaming and finding some really good sort of strength in numbers, or I guess combinations of data sets, and being able to disseminate that kind of information, particularly with an enterprise geodatabase behind it, SQL Server, and the power of Power BI being able to integrate multiple data sources, and with the DAX programming language behind that, you can start taking the best of both worlds, GIS and the analytics and the display widgets out of Power BI, and really building some comprehensive informational websites. All of these, to this point, have been internal at Stanley, but they're really supporting our marketing teams, sort of historical tracking of where our proposals have had, success and not success, and, what kinds of credentials do these types of projects lend themselves to Stanley to. And so using it as a resource internally to generate more work for us in the future. The combination of that with the integrated master database behind it is providing some really, really big dividends.
Which, and this makes a lot of sense. And for the audience, right, anything like GIS related, right, it's all still data. The caveat is it's more, right, like spatial in nature. So there's less of, I guess, in the way I view your guys, right, is like there's like an Excel or a numbers crunching component to it, but there's also a spatial component that, like we talked about earlier, right, like roadways, maps, highway, etc. And, it's an interesting topic because you guys hear, right, it's like data's the new gold, data, everything, but either way, you guys, it sounds like you have a workflow to get data, from whatever GIS application you're using, whether it's in the field or it's in the office, and then pass to what sounds like a separate data team to then further analyze and essentially provide business insights in whatever way the project dictates, it sounds like.
That is true, yes. And I'll give you an example there. So, using like Power BI, Tableau, for example, we do have a climate change group within Stanley Consultants, and that's really all they focus on is just, from a kind of an engineering asset management standpoint, how is climate change going to affect our clients? So let's look at like sea level rise. So we have a lot of clients who, are on the coast and they're trying to understand, okay, if the sea does rise, 1 or 2 meters or so, how is that going to affect the infrastructure? So we have, counties and states and even some of our DoD clients who have infrastructure right along the coast, and that might be a bridge, for example. So that bridge right now is above sea level, but in 20 years, it might not be. And so putting together all those models using GIS software, they can put together models that say, okay, if the sea rises this much, here are the bridges that are going to be underwater. And they also have to take into account, tidal effects, also just, flooding. It may be just like surface flooding from rainwater that could not get into the ocean as quickly as possible because the culverts or something could be backed up from seawater, as opposed to when they were dry, previously. They have to take into account all that infrastructure and help the client budget for what could be coming up. And that's pretty important. I mean, it's not just bridges and culverts, all the utilities. Think about it. If you have pad-mounted transformers, those are very expensive. Switch gear on the electrical side, all your ITN, like your comm nodes, if you just kind of, it's interesting. If you just kind of drive around in your car and things kind of take for granted again, you just kind of drive around and start looking at things like, boy, if the water comes up a meter, what if this is going to be underwater? And it's buildings, it's hangars, it's runways, it's so much. And, taking that data, put into Power BI, and then putting a dollar amount to each one of those pieces of infrastructure, then you can start to put together all those nice visualizations that really show, hey, you're going to have 1,000 bridges underwater. You're going to have 2,000 transformers. You can start to put together true actual dollar amounts to your clients, and then they can start to determine, okay, boy, we need to start budgeting X millions of dollars this year and then next year. So those capital improvement plans and just some of the maintenance plans, Power BI, GIS, Tableau, you start using those tools, it's extremely powerful.
And, I think this is kind of I would say, from the engineering side or the consulting side, right, we just take infrastructure for granted, right? But it is really a complex series of nodes, decisions, right, entities, like you just said, like sea level rise of a meter means, X amount of infrastructure is now underwater, right? And it's really cool to hear that because you don't always think of it in that manner, because what you see today and what you see tomorrow, it all looks relatively similar, right? But then projecting a couple of years out, you could see some significant change. But it sounds like you guys have a pretty good handle on quantifying what that means for your clients.
Yeah. And sometimes, it really just brings to light some really tough decisions that are going to have to be made here pretty soon. On the military side, we have bases that are right on the ocean, and they're looking at some of these bases, half of them, will be underwater, or half the base will be underwater. So what do? Do you invest the money to bring in fill, elevate the runway, taxiways. I mean, that's hundreds and hundreds of millions of dollars or billions of dollars, perhaps. Or do you close the base and move inland? Take that mission and move it inland. That's a really hard question, but starting to do that now is better to be prepared to get that plan put together as opposed to when it actually does happen. So it's important.
And realistically too, Drew, your example of, a meter sea rise, it's not out of the realm of possibility, but, that's a fairly extreme example on a sort of a more local level. Even if, say summers get a little bit hotter, just anywhere in the United States, well, a lot of schools maybe have not had air conditioning built into them because they haven't needed previously. Well, now if you have 30, 40 kids packed in a school room and the summer is quite a bit hotter, can those kids now learn as effectively in this hot, potentially sweltering room? So getting this information, sort of planning ahead, automating the information pulls from, national sources, integrating it, using our own science, resilient analytics group to discern what's potentially could happen, can start guiding clients on, if the sea rise goes up, if the temperature goes up, this is what happens to your infrastructure. Your pavement starts to fall apart a little bit faster for every degree that the temperature goes up on average. It's going to degrade faster. You can start long-term planning if you have the range of outcomes that the spatial and temporal and cultural information all mixed together into an analytics platform. And by that analytics platform, I'm talking about both Power BI and GIS, with sourced data behind it.
These are excellent points. And then think about so we talk about long-term planning now, and then I assume, hey, maybe some of your clients are going to ask you to execute projects based on these forecasts, right, and these budgets, which of course we all know in kind of the civil engineering realm, at least, right, and many others. There's an aspect of field data collection, kind of like we talked about earlier. So one for you, Hart. So how critical is the role of mobile GIS applications like Survey 123 and Quick Maps in the collection and QA/QC of field data?
Oh, it's critical. Getting the wetland scientists out, seeing the wetlands, whether they're there, they're not. The NWI data is a great starting point. It's not necessarily true to life. It doesn't get updated all the time. It's a great starting point. Field verified is obviously better. And the faster you can get that data out in the field, collect that authoritative data and back into the desktop, it becomes available to everybody that didn't go out there. So I was recently on a trip collecting 3D LiDAR data on the interior of some of these buildings that we needed to renovate. They had no as-built plans. And so the designers needed to know where they were starting from. And the 3D LiDAR project basically gave us an as-built, where are we starting from? And then this is what the client now wants to get to. And combine that with the Survey 123 and the power of doing, effectively field calculations. We do quality assessments, of things. You go out in the field and you say, well, here's something that's, on a scale of 1 to 10, it's a 10 for quality. We don't have any problems with this. Here's one that's a 2 in quality. And if it happens to break, the whole plant shuts down. Well, the expert is out there with Survey 123 and gives it those ratings, and real time on a dashboard back in the office now pops up a big red flag because this one is an immensely critical point, piece of equipment. The equipment owners can now say, well, wait a minute, I need a budget to fix this one because if this happens to break, the whole plant goes down. So that's an extreme example, but you get real. I love the real time, and I love getting experts with their eyes on, and then allowing everybody else to use that data.
And it's a great compilation of some of the other technology applications that we've had on the show previously, right? So you had mentioned LiDAR and other forms of, so like you mentioned LiDAR, other forms of reality capture, right, and creating as-builts. We've had computer vision experts on talking about, hey, like, what do these cracks in a roadway mean, or these potholes, and what does that mean for my long-term maintenance and planning, right? But it sounds like at the end of the day, it's all just, different forms of data depending on the specific application, updated in real time, what your experts are actually seeing in the field, bringing that back to the office to help you and your clients make more informed decisions.
100% agree with that. And that sounds so easy, but obviously, the devil's are in the details there.
Details, absolutely.
And, that's obviously the gold standard to shoot for, that everybody just walks out in the field and does what they need in the field, and then everybody can see it back in the office. And, that's why we're here as the GIS team, to be able to build that platform to allow people to do things easily and quickly and smoothly. So we've transitioned from being sort of the desktop cartographer to being the data planner, the data manager, the platform creator and manager and overseer, administrator, I guess, in a number of different realms, from both the desktop and the field and database schema developments. And it's what really makes GIS so interesting, is that we get to put our fingers into so many different pies and play with them all. So,
and kind of what I'm hearing from you guys is, right, like you guys are really supporting projects, right? Projects and project teams. And you guys are the experts in a piece that, let's just say in some firms, right, an engineer who's an expert in it might be tasked to do something somewhat GIS related, right? But now that you guys are on in support of these projects, right, like everything we've talked about, you're able to provide a level, kind of like a next level of expertise. And Drew, I want to ask this question specifically. Do you have any examples of cross-platform GIS and data analytics applications that have extended the reach of project data in your work?
Oh yeah, that's a great question. Yeah, there is several projects that come to mind, but I'll just use one. So we're working down at Tyndall Air Force Base in Florida. I don't know if you remember, a couple of years ago, Hurricane Michael came through, and I think it was a Category 4, Category 5 hurricane, just completely wiped out the base. And they, chose to essentially reconstruct that base, and it was kind of the base of the future. So in order to expedite the work, instead of just having one design firm and one, construction contractor, I mean, this is, I think they're up to like $6 billion worth of work. They had to basically break that part. So, one firm is in charge of the hangars, the aircraft hangars. One firm's in charge of the airfield pavement. One firm's in charge of, the support facilities, you name it. So I think in all total, there was 12 different design build contractors that were out there. And Stanley Consultants' role was to actually be the program management piece to that. So this being such a large program, you have, with 12 different design bid contractors, you have 12 different construction schedules, design and construction schedules. And there are certain things. So if you're a contractor that's in charge of all of the utilities, buildings are pretty worthless without, support infrastructure. Like, if you don't have electricity, your building's not going to be very useful. So in order to coordinate all of these 12 different contractors, Stanley Consultants basically put together, merged their schedules, and then we would flag whether or not there was some issues with that. Now you have to somehow put together some visuals that say, okay, some conflict detection visuals that say, okay, if this project is not completed before this project, there's a red flag that needs to go up. How do we do that? And Hart, he did a great job. He put together a custom application where we took all of the basis GIS data, so all the projects, the utilities, but we also merged that with Primavera P6 calendar to essentially show when these projects would, we had different color-coded visuals that would show, okay, it's in a planning phase, it's in a design phase, it's construction, it's supposed to be complete at this point. And then for some buildings, we would also have like a beneficial occupancy date. So if you're a wing commander at Tyndall Air Force Base, Nick, the one thing that you probably care about is, when can I bring airplanes to this base? When can I fly jets? And that's something that they looked at us to determine is, okay, we need to make all these calendars come together so that we can provide sort of the high level, sir, ma'am, here's when you can bring, new jets to your base. So what we did is we took GIS, and then we merged that with P6, able to put together kind of like a time slider, so that any date, any point in time, you could actually slide that over to a calendar and say, here's all the projects, and each one, the color coding would change based on whatever the status of that particular project was on that particular date. So that way, whoever the user is, it could be somebody that's, it could be the contractor, it could be, the wing commander, it could be somebody, one of the design build contractors. Anybody could take a look at that and start to manipulate that, time slider to determine, okay, they're going to be done at this date. I need to, either work faster, hire more resources to get my project done sooner, so that way it doesn't impact the overall schedule of this giant $6 billion 12 design, bid builder contractor. So it was very powerful to have all those cross-platform GIS come together, as well as the data analytics piece.
And I imagine, right, with construction, right, one thing that's consistent is change. So I imagine that as there were changes, throughout schedules or designs or what have you, right, that real-time data piece was probably pretty helpful because, going over the slider and saying March 4th, right, may have looked very different a week ago compared to 6 months to a year ago, right?
Yeah, that's a really good example, Nick, because that came up all the time is, we would constantly be getting schedule updates and we constantly have to track, okay, what does that do to the overall schedule? Did it change it? Did it improve it? Did it, is this something, oh boy, that just, this delay just cost, 5 months of delays because now all these other contractors that we had lined up have to wait for the other person to get done. Hart also mentioned the Survey 123, the field data collection component to it. So, kind of on a cross-platform example is that we would also use it in terms of construction inspection. So if you're out there with a tablet or even your smartphone, I mean, it doesn't even have to be, some big tablet. You could just pull it out of your pocket. You have your smartphone there loaded with the Survey 123 app, and you can go and place the point where you are. So if you're at a project site, you basically just go, place the point, and then a custom form will pop up. And in the custom form, we basically put together pick lists. So to kind of help streamline and standardize the data, you can come up with pick lists. So let's just say that you're inspecting maybe some materials that are being hauled in, and you want to make sure that the rebar, for example, is good quality. So when it's brought in, the construction inspector can, say, okay, is it good, fair, poor? Now, if it's poor, then, maybe you color code the different dots on the map accordingly. So maybe it's green, yellow, red. And furthermore, if you are the government and you're trying to understand, okay, is there some issues out in the field that we need to correct? All of those ones that are at poor, you could then create a custom report. Maybe it's a weekly basis that just flags, okay, here's the list of all of the issues that we have out on site. Maybe it's safety. Maybe there's a contractor there that's just not doing things very safely. And you can basically say, okay, send that report to the project manager on the government side, and that project manager then has a nice, succinct list of issues that they have to address. So it's used for those large programs, GIS, it's used so many different ways, and that cross-platform example is a good question.
Yeah, and absolutely. And coming from, right, an inspection-based industry, I can relate, right? Because sounds like there's, in this specific example, there's 3 pieces of info, right? What is the problem? Where is the problem? And who do I go to get the problem fixed, right? And if you don't have all 3, which it sounds like GIS basically can bring together very easily for that inspector in the field who, right, they may not even know what GIS stands for.
Right.
They're able to use the application very simply and essentially get people the data they need to make decisions to move projects forward.
Exactly. Yep.
This has been great, guys. Very informative session. And one for both of you as we close. So what piece of advice would you like to offer other engineers that are listening and are looking to integrate these types of technologies into their work effectively? And Hart, why don't we start with you and your kind of final words of advice?
What words of wisdom? I guess word of wisdom would be GIS is not just cartography anymore. And I mean, there's beautiful maps out there that GIS specialists put together, and there will always continue to be, but it's going to be less and less cartography is the only thing that we do. It's really translating more into a data science sort of endeavor with programming languages, maybe how data is structured, so sort of a data engineer. And then understanding, the movement and flow, sort of an ETL, extract, transform, and load process. Getting data from a source through an application to another source so that people can use it. That's becoming, I think, sort of critical to what, high-end and high-throughput GIS platforms need to do. And so the people running those need to have a handle on that more than just sort of the cartography.
Yeah, absolutely. And Drew, what about you?
Yeah, I would say if I'm talking to somebody that's still, in school and college, I would say take those courses, take those GIS courses, even if you're in an engineering field, by all means, please try to pay attention to those, take those seriously, because that's what you'll be using a lot of, especially we've been pleasantly finding that a lot of our water resources engineers are coming out of school with a fair amount of GIS coursework behind them. They have a pretty good understanding comparatively to some of the other disciplines. And really, I mean, some of the engineers, they can't get their jobs done without GIS and without doing the modeling within some sort of GIS platform, whether that's Esri or maybe that's XP Swim. I mean, there's so many other CAD-based GIS platforms that we'll call them, that they need to kind of understand how those work in order to do their work. Again, when I started 15 years ago, some people, I had engineers who were, kind of towards the end of their career would literally take a highlighter and start to map out a topo drawing and say, hey, this is where we plan to put a flood wall or a levee. What's that going to, is this enough flood protection if we put it here? Can you please model that in GIS? So just that efficiency of knowing GIS and using it day to day to get your work done, I would say, please, take that seriously. You're gonna impress your employer quite a bit more if you have that background.
Great words of wisdom from you both. And again, thank you so much for joining us today. And if our listeners, maybe want to ask more questions, say about specific applications, or Drew, maybe what courses they should take, right? Just as some examples, what's the best way for them to reach both of you?
Yeah, email is always great for me. Email it's rotschafer@stanleygroup.com, and I'm going to have to spell that last name. So it's ROTSCHAFER and then DREW @stanleygroup.com.
Yep, and my email is similar. It'd be Gilchrist Hart, GILCHRISTHART @stanleygroup.com.
Wonderful. And for those of you listening, both of their emails will be in the show notes. So it'll be nice and easy for you to copy and paste just in case you didn't have a pen on you. But again, Drew and Hart, thank you so much for joining us today.
Yeah, thanks.
Thank
you. It's a pleasure. Thanks for the opportunity.
Till next time. Please remember, you can find the show notes for this episode at aectechpodcast.com. There, you will find a summary of key points discussed in today's episode, as well as links to any of the resources, websites, or books mentioned during this episode. Until next time, I wish you the best in all of your engineering and technology endeavors. Thank you.